Welcome everyone to this short demonstration of chatting with your car's manual. I built out this use case because I think it's a great example of how organizations can use generative AI to help their users. Car manuals have gotten longer and longer. There are several hundred pages these days, and users rarely read those manuals. However, they certainly have questions when they're sitting in the vehicles and try to operate them. So the way I'm going to approach this demo is I'll give you first the user experience that I built out with this application. Then we'll talk about how I built it, as well as behind the scenes look of how this application actually runs. And then we'll talk a little bit about why I think this is relevant for other enterprises as well. One disclaimer, I'm not affiliated in any way or form with Mercedes-Benz. I purely built out this use case out of personal interest for both the vehicles as well as the technology behind this application. All right, so as a user, I can load up this web application, and the first thing I'm being asked is to identify my vehicle. And the way I do this is by using this dropdown. First, I'm going to select the model year, then the actual model, in my case, an E-Class. And then depending on the model, there might be different body styles, so maybe I do have a wagon, and then immediately an image of that selected vehicle is being displayed. If I did make the wrong selection here, I should probably now be able to identify that and make a correction. For example, I might actually have a coupe. So now that I've selected my vehicle, I can continue to interact with this application through chat. So I can ask questions about the car. For example, how do I change the AC? And the application will give me guided steps on how I change the AC in this car, and also give me a link to the actual owner's manual. Let's ask a different question. Where is the flacon for the air fragrance located? So in this case, the application gives me, again, the information. It is located in the glove box, and it also gives me a reference to the user's manual if I need more information. Looks like this information is on page 140. So I can click access the full owner's manual. The owner's manual will open up in a separate tab for this specific vehicle, and I can then scroll down. Let's go to page 140, and here indeed I see an illustration as well as instructions on how to change or access the fragrance flacon in the E-Class coupe. Now that we have seen the user experience and how useful this application can be to assisting customers and users with questions about their vehicles, let's talk about how I built this. This is the implementation overview of the chat application we just saw. It uses the concept of Retrieval Augmented Generation, which really helps to add additional context to a chat model based on the user's question. And we retrieve that information from what we call a vector database based on the query that the user put in. So we give it founded knowledge that the model then can use to answer the user's question. So as you can see, all of that is running on premises in a completely air-gapped environment, in the sense that we're not making any calls to hosted APIs, like, for example, ChatGPT. Let's talk first about some of the service components that we need. The first service that we already interfaced with is the Streamlit frontend. That's the web UI hosting the application logic, as well as some of the components we need to interface with the LLMs that we're using. The other component we already directly interfaced with is the web server up here that is serving our original PDF manuals if we desire to access the full manual. In the backend, we have a few more services that are important, namely our language models. So I'm using two language models. For the chat model, that is basically conversing with the user, I'm using Llama 2 7B, directly pulled from Hugging Face, so it's not changed or fine-tuned in any way or form, and I'm using Titan ML to host this model. I'm also using an embedding model to create what we call embedding vectors that really allow us to do a vector search against our database. And we'll talk a little bit about more how that flow works. But for now, just think of it as a model that translates human readable text into a vector that then we can use to compare it to other vectors. Again, I'm using a model from Hugging Face, in this case, the Mistral embedding model here, SFR embedding Mistral. And I'm also pulling that directly from Hugging Face, and I'm also using TitanML to host this on-prem. Both of these models are running on an NVIDIA A100. The other service that we briefly already mentioned here is the vector database. I'm using VV8. The vector database holds all of the documents that are embedded, as well as can do a search. So when we get an embedding from the user search side, we can find the relevant information in that vector database. And the way I do this is by doing obviously a vector search, but then also applying filters, so I can only receive documents that are relevant to that particular car that the user selected. And then up here on the top right, you see an orange box that currently is optional. So as I mentioned, I'm not actually fine-tuning any of the models that I'm using right now. And that's simply because the performance is good enough, and most of that knowledge or the verbiage that I'm using around Mercedes is public knowledge, so these PDFs are publicly accessible. However, if you were to build this in an enterprise setting where we have proprietary documents, proprietary knowledge that is not out on the public internet, you might want to fine-tune those models to improve the chat as well as the retrieval performance with the embedding model. And for that, we basically have the option to use Determined AI, which has been acquired by HPE, is now known as Machine Learning Development Environment as the enterprise version. We can use that to fine-tune Hugging Face models and then also load them as chat or embedding models using TitanML. So I think the easiest is to really briefly step through the workflow here. It all really begins with loading PDF manuals that I scraped from the manufacturer's website. And I'm converting those PDF files into text files, and I'm parsing them and removing any weird characters so they're in a form that they're consumable by the application. Additionally, I'm already using a language model, specifically our chat model, with a specific prompt template to create metadata about these manuals. So in my case, the metadata is all about which vehicle model, which vehicle year, which body type, where the information is coming from. All of that I can basically generate automatically using a chat model with a very specific prompt template. And that's really step number 4. After I have that metadata and after I have my text from the manuals, I'm going to chunk those text files into smaller pieces. And the reason I do this is because we have a limited context window with these chat models that we have to adhere to. So I cannot simply paste the entire manual into the model's context window to answer a question. I need to find a relatively small piece of text that describes the answer of the question and add that to the context window. So therefore, I need to chunk these text files. And then for each of those chunks, I'm basically creating those embeddings. So the vector representation of that chunk. And I'm using, obviously, the embedding model that I'm hosting here to do that. Once I have those embeddings, I'm taking all of them and I'm creating an index, a vector database index that can then be consumed by our vector database, which is VV8. So that's really step 8, and then loading that vector database in step 9. As soon as I have that set up, I can basically focus my attention towards the application logic and the user's interface. So when the user asks a question, right, what happens in the background is I'm taking the question in, I'm adding it into the chat history, so I always keep track what the user is asking. And then I'm going to apply the application logic to first do an embedding of the question itself. So as I did with the chunks of the manuals, I'm basically creating a vector representation of the question. That's really here this step here that I'm using. And then once I have that vector representation, I'm going to query the vector database in step 14 to find the most relevant chunk or the most relevant passage of the user's manual that can answer the user's question. That's step number 14. As soon as I have that, I'm going to take my prompt template that I have, the user's question, as well as the retrieved information from the manual, and send it off to the chat model in step 16, where the chat model is then capable of synthesizing an answer based on the user's question, as well as the information retrieved from the user's or the owner's manual. Now, in step 17, that's where we provide that answer to. And The interesting thing with step 17 is that actually it's a stream. So it looks like as if the chat application is typing, and you saw that in the demo as well. So it's streaming those tokens that it's generating live to my application logic. And then I'm basically putting it into the chat window, showing the user that basically the application is typing and answering the question. With that, we then have the answer to the user's question relevant to the vehicle that the user selected. One other thing that I'm doing, and I kind of skipped over this, but here in step 10, I'm loading the metadata that I previously created. So I always know, one, which vehicles are available in the vector database, and I can give the user the exact selection. So the user never selects a vehicle that is not available. And I'm also using that metadata to then figure out which manual to show and which vehicle to limit the search for in the vector database. So when the user asks a question, I already know which vehicle it is about, meaning I can put a filter on this, so I only retrieve information from the vector database pertaining to that particular vehicle. And I'm then also able to generate a link to the original owner's manual, which is really here step 21. So this is the button that we saw, access full owner's manual. As soon as the user clicks that, I already pass a URL to the original owner's manual that is hosted on this web server, and the user can read the full manual if he desires, or if it desires to do so. So that's really the end-to-end flow. A couple of things I do want to call out here is, given that this is a lot of steps, it's really important that we focus on performance, like the number of tokens that are being generated for the entire workflow. So as soon as the user types a question and submits it, everything that's here on the slide here in this lower half needs to be executed relatively fast, as the user really doesn't want to wait for an answer. As well as all of this needs to somehow being orchestrated as a pipeline. And I'm actually using HPE's MLDM, machine learning data management software, which has been acquired by HP through the acquisition of Pachyderm last year, to basically orchestrate this whole application, right? And this really is important, because if you think about keeping this application alive as, like, in terms of an application lifecycle in an enterprise setting, if the manufacturer releases a new car, how do we keep this application updated so the user can basically immediately ask questions about the new vehicle that was just released? And that's the way where we have those data-driven pipelines where I can orchestrate this end-to-end, and I can simply commit a new PDF manual into the application pool, and then all of the subsequent steps will get executed automatically, so that I can immediately ask a question about the new Mercedes GLE, S-Class, whatever comes out, right? So let's take a look behind the scenes of how this pipeline looks like, and then also talk a little bit more about the fine-tuning part before we wrap it up of why I think this is relevant for the broader enterprise segment. All right, this is the behind the scenes of the implementation view you just saw on the slide. It's running in the HP machine learning data management software, also known as Pachyderm, and it really has all the steps we just saw on the slides. So a brief walkthrough, all of this is fully data-driven. So if we start on top here, we see our input repository for our PDF files, our car manuals. We see the input repository for our images for the vehicles, and then we see all of those steps, right? The conversion to text files, the chunking, the creating the embeddings, as well as the creation of the vector database index, and then running these services that were on the right-hand side, the embedding model, the chat model, the Streamlit front end, the vector database, and then up here also our Apache 2 web server to host those PDF files. And as I mentioned, if I were to update this application with a new vehicle, all I really had to do is commit or upload a new PDF. I can actually do this from the UI. So if I go into repo actions, you can see I can upload a file, a PDF. And as soon as I do so, this whole pipeline executes and updates the front ends as well. Meaning if there's a new vehicle, I commit it into this input repository. All of this runs within a few minutes, and then I can immediately ask questions about the newly released vehicle. As I also mentioned, for this specific project, I did not fine-tune any of the chat models or the embedding models. I do have a project that I did do this for. So if we go over here, we have what we call plugins that allow us to fine-tune those models based on the data that we're putting in. So in this case, you can see this is a RAG pipeline that is a little bit simpler, but it has a fine-tuning step here. And that fine-tuning step directly connects to our training environment, which is the machine learning development environment, also known as determined AI. So if we actually hop over to the training environment, we can see all of my projects here. So those are all training projects, modeling projects. And if I go into my workspace, my PDK demos workspace, and I look for my SGPT retrieval app, so in this case, we used an embedding model called SGPT, you can see we actually fine-tuned this, a 5.8 billion parameter model on 4 GPUs, and I can look at my loss curve here. This is really the fine-tuning process, the metrics that we're collecting during the training, which is the training loss. I can look at my checkpoints. I can look at my code, my hyperparameters. All of that is part of the training environment. So if you do have to fine-tune either your embedding model or your chat model, you can do so directly from within those pipelines as well, using HP Machine Learning Development Environment or the open source version, Determined AI. Now that we've looked at the application in terms of user experience, but then also from the implementation view, I want to use this last section to talk about why it matters. Why should I consider building an application like this on premises with my own tools that sit on-prem, with my own language models hosted locally, when there's options available like ChatGPT, OpenAI services hosted, or other public offerings that I can simply plug into? For me, it really comes down to 3 aspects. And the first one is independence. When building a GenAI application like what we just saw, in an enterprise setting, it oftentimes means that you're committing yourself to running that over an application lifecycle. That's oftentimes several years, potentially tens of years. Building this application around public APIs that often change or maybe around for a couple of months, maybe years at this point, might put you at risk of building something that is heavily dependent on third-party services. Which means if it changes, you'll have to change your application, and it also means it might limit you in adopting some of the latest and greatest technologies. To give you an example, the open source model space is evolving very, very quickly, and I can easily plug in a new chat model. I'm using Llama 2 right now, but Llama 3 is supposed to come out later this year. I can plug in Llama 3 without making any changes to my code and running that locally. If I were to be on a hosted environment, I might have dependencies on when that provider is going to adapt Llama 3 and make that available to me as a user or as a consumer, as well as given a certain price point that they will likely make this available to you. The other part is the platform freedom. With the environment and the platform I just showed you, as well as the code implementation, you have the flexibility of running this wherever you'd like. Even if you choose not to use some of the pipeline capabilities or fine-tuning capabilities that I showed you, the code itself is agnostic from the platform and can be run on-prem, in public cloud, hybrid, on different types of environment without needing to change. And that's a huge benefit as you're looking to optimize your application, potentially shifting your application around, as well as scaling it out. The second reason is really all about privacy and security. We have many organizations that still have data on premises, whether that's by design or because of regulations. At the same time, those organizations want to build generative AI applications to improve their efficiencies and leverage some of that technology. So building out those use cases on premise is extremely important for them, and doing so sustainably where they can sustain the life cycle of that application, and that's where we go back to the first point about independence, is crucial. The other part, even if you don't have a lot of data on-prem or you have to be on-premise, think about the compliance and regulations aspects when we're putting out user data, potentially sensitive data, into those chat models. As soon as we are calling on a third-party cloud endpoint to call up an LLM, we are out of control in where the data goes and how we're actually governing that data. Running everything on premises in a regulated environment behind your firewall is the best way to securing your GenAI applications. Now, the last reason is all about performance. When we think back about the demo that I did in the beginning of this presentation, the answers came up very, very quickly. It's all about the number of tokens generated per second. Arguably, the demo I showed you runs faster than ChatGPT, and that is despite of the fact that it's actually retrieving content from your own data on premises. So model performance, as well as the associated cost of running those models at a certain performance level, matter. And we've seen it time in and time out again, that running on premises over a certain amount of time will give you the best performance per dollar for your generative AI applications. But again, you need to be able to do so sustainably with a platform that scales with you, that allows you to build out those use cases. So in short, the independence, privacy and security reason, as well as performance concerns, are some of the top reasons why you might care building out your generative AI applications in a controlled on-premises environment.